In today's lesson, we'll be looking at the topic of probability, where we can find out the probability of any event happening. So let's start off with some notation here. The notation begins with P of E, okay? So the probability of an event occurring. So each outcome in this event, okay, has to be equally likely so that the probability of each event is the number of favorable outcomes over the total number of outcomes. So in example 1, we're going to look at a card is chosen at random from a set of cards numbered 0 to 9, meaning there are 10 numbers in total if you count all the cards here. Find the probability of selecting the card numbered 8. So there's only number 8 here, and there's only one of them out of the 10. So we say the probability of getting 8 is basically 1 out of 10. Question B. Find the probability of selecting a number less than 4. So the number less than 4 will start with 3, then anything under that will be also accepted. So 3, 2, 1, and 0. There are 4 numbers. And how we write that is we write P of less than 4 is equal to 4 out of 10, and we can further simplify that to become 2 out of 5. Question C. The probability of a number of 5 or more. If it's 5 or more, then 5 is acceptable. We want 5. We also want 6, 7, 8, 9, 10. And there are 6 numbers in total. So the probability of number 5, okay, 5 or more, will be 6 out of 10, which can then simplify to 3 out of 5. But that's how you do question C. Right, moving on. Now, the range of probability, as you saw before, each of these answers were fractions. And in this particular case, they are proper fractions. They extend from a probability of 0 to half to number 1 as maximum. An example of a possible event is, say for example, choosing a green marble out of a bag of red marbles. That can't be possible. Even chance, maybe selecting a red card out of a deck of cards because half the deck is red, half the deck is black. And a certain event would be something like choosing a blue marble out of a set of blue marbles only. So that will be 100% possible because it's blue marbles. So those are just some examples of probability I can mention. There are many more. The next thing we're going to look at is complementary events. The complement of an event E is made up of these outcomes in the sample space that are not E. Sample space just refers to all the possibilities available. And in this case, the complement of an event E are the ones that are not E. So they are basically opposites. This is represented by the probability of E with a line on top, or the bar on top. Complementary events are events that together make up all the outcomes. So the probability of events plus the probability of the complement of its event is equal to 1. So say for example, if I did the probability of blue, then I have to plus it by the probability of getting marbles that are not blue, and that should equal to 1, okay? Because this includes all the rest of the marbles that are not blue, whereas this one includes the blue one. Now if I rearrange this equation just by subtracting P of E to both sides, this will cancel. That means what's left is this formula, which is over here. This lets you calculate any kind of complement of an event. Example 2. Question A. List the sample space when this spinner is spun. We've got 5 colors here. So we can say the sample space, beginning with our curly bracket and inserting anything within the curly bracket with what it has on the spinner. We can start off with green, then blue, then yellow, then red, then white. Okay, question B. Find the probability of red. Well, red only happens once out of 5. So we can say P of red is equal to 1 out of 5. What is a complementary event to the spinner landing on red? The complement of that would be not landing on red. So that means you can write red with a bar on top, or you can write probability of not red. It's up to you which one you want to write. But each of those should equal to 1 minus the probability of not red. Oh, sorry, probability of red, I should say. So these are opposites of each other. Okay? Now, question D. List the outcomes in the complementary event. So the complementary event, remember, like what I said before, the probability of not red is 1 minus the opposite of this, which is red. And if I include those that are not red, that will be white, green, blue, and yellow. Okay? So there are 4 that are all together. So for question A, probability of not red. Now you can straight away see that it's 4 out of 5, but I'm going to use this formula here where we've got P of not E is 1 minus P of E, which is the probability of the event. Oops. Okay, so that will be 1 minus the probability of red, as I said before, and the probability of red is 1 out of 5. So if we get 1 minus 1 out of 5, we do get 4 out of 5, which is the same thing as counting these. Let's move on. Exercise 12.01. A letter is drawn at random from the alphabet. How many outcomes are there in the sample space? Well, in the alphabet, there are 26 letters. So we're going to say 26 letters. Are all the outcomes equally likely? Yes, they are, because each letter only happens once in the alphabet. And what is the probability of choosing a vowel, which is A, E, I, O, U? There are 5 letters out of 26, okay, for the vowels. For D, what is the probability of selecting a letter from the word probability? Okay, so let's have a look at what kind of letters there actually are. So there's the letter P, R, O, B, A. Now we don't want to repeat the same letters. Okay, we just want to see how many letters there are, okay, that are involved in the word probability. So we just don't include that B again because we already included B already. And then we have a look at the next letters. So I, L. I've included I already, so I'm not going to write I again. Then T, then Y. So if we have a look at the number of letters here, there are 9 letters. So there will be a chance of 9 out of 26 chance of choosing a letter from the word probability. Okay, so in summary, just include every letter of the word probability just once. Okay. Question 3. Now, for question 3, if you're not familiar with cards, there are 4 suits. So the suits here are basically hearts, diamonds, clubs, and spades. They are the symbols in the center of each card. 2 of the symbols are red. They include the hearts and the diamonds, as seen in the shapes. 2 of them are black, which are clubs and spades. Okay? So there are 13 cards of each kind. I'm going to write 13 here, so you know that. So 13 of each suit. Now, a card is selected at random. Find the probability that is a black card. So black cards are only these ones here. They involve half the deck of cards, which means a total of 26 out of 52, or you can just say half. For question B, an ace. How many aces are in the deck? Well, the aces are the first number in the deck, so there's 4 of them here, 1 of each suit. out of 52. That simplifies to give you 1 out of 13. An even numbered card. So even numbers represent these ones here. So there's 4 2s, 4 4s, 4 6s, 4 8s, and 4 10s. So we can see there are 1, 2, 3, 4, 5 different numbers that are even, but there's 4 of each of them because there's 4 suits. So we're going to do 5 times 4, which is 20 out of 52. And that gives us 5 out of 13. Let's simplify it. Part D involves picture cards. Picture cards are basically Jack, Queen, and King, which are each of these 3 cards here. So in total, as you can see, if you multiply how many cards are here on the bottom and how many cards go up vertically, 3 times 4 gives you 12 cards. So there's a total of 12 cards, which are picture cards, out of 52. And dividing by 4 gives us 3 out of 13. Hope that makes sense to you. All right, let's move on. Question 4. A die is rolled. What is the probability of rolling a number greater than 2? Well, when you roll a dice, there's 1, 2, 3, 4, 5, 6 as our sample space. A number greater than 2 represents 3, 4, 5, 6. So we're going to say for the first question, it is 4 out of 6, which is 2/3. B, a prime number. Prime numbers can divide by itself and the number 1. Now, the smallest prime number is not 1. 1 is not a prime number or composite. The smallest prime number is the number 2, which has factors of 2 itself, because 2 times 1 gives you 2. The next one is 3. Okay? 4 is not a prime number because it's composite. It has factors of 2, 1, and 4. The next one is 5. That is a prime number. And 6 is not a prime number. So there's only 3 numbers out of the 6 which are prime numbers. So that's equal to half. Question C. A factor of 6. Factors of 6 are 1 times 6, 2 times 3. How many numbers are that? That includes 4 out of the 6, which is equal to 2/3. D, a number less than 4, with a number 3, then 2, then 1. That occupies 3 out of the 6, which is also half. E, a number greater than 6. Okay. Is there any number greater than 6 here? No, because our max number is 6. So we say 0 of them out of 6, which is 0. F, a number less than 10. A number less than 7. So all of these numbers are less than 7. So we're going to say all of them, which is 6 out of 6. And we're certain that will happen, so that's equal to 1. So we let that equal to 1. All right, hope that makes sense to you. We're going to move on to the next question. Question 10. For each event, write the complementary event. So, for question A, where it says selecting a consonant from the alphabet. Okay, so the opposite of that is not selecting a consonant. And you're just going to make sure that apart from consonants, what else are there? There's only vowels, okay? So we can say or selecting a vowel. Now for question B, the weather tomorrow being sunny. Now the complement of that is not raining, because you're saying that being sunny and raining are the only 2 types of weather out there. Okay, and this is what I typically get a lot of times from many students. That's not correct, because the weather can be hailing, could be cloudy, could be snowing, could be a lot of things. It could be clear even. Okay, so the complement of the weather tomorrow being sunny is just not sunny. Okay, that would summarize every kind of weather or type of weather that is not sunny, including the ones I've said. C, a traffic light showing red. So we can say not showing red. Okay. So you'll notice that from the first 3 questions, I always say not this, not this, not this as a complementary event. That's a safe answer. But we know that for traffic lights, they can be red, yellow, or green. So we can say or showing yellow or green. Question D. Selecting a spade from a normal deck of cards. So we can say the opposite of that, which is not selecting a spade. Okay. Or if you're certain to know or list what other suits there are, which we learnt were clubs, so the other black card, diamonds, or hearts. And I should say selecting these. So selecting a club, I should change this to a club, a diamond, a heart. There we go. Question E. Hitting a bullseye on the dartboard. The opposite of that is not hitting a bullseye. F. Selecting a blue ball from a bag containing blue, red, and yellow balls. Well, what other balls are not blue? We can firstly say not selecting a blue ball. But apart from that, we can say also or selecting all the other colors that are not blue, which are the red and yellow balls. Okay. So for any of these questions, all you're going to do is write down the complementary event, which is not selecting whatever it says there. That's the most safest answer. Okay. Question 12. Dylan buys a ticket in a raffle, which 50 tickets are sold and there is only one prize. What is Dylan's chance of winning the prize? Write your answer as a fraction. So if there are 50 tickets and he only has one ticket, she only has one ticket, I'm not sure. This will be 1 out of 50. And as a decimal, well, that would be 0.02. If you tapped it on your calculator, press the SD button or time, yeah. Okay, so that will be 0.02. And if we multiply this by 100 to get to a percentage, we would get basically 2%. All right. Calculate the probability of Dylan not winning the prize. Write your answer as a fraction. So not winning a prize would be 1 minus the probability of winning a prize. Okay? So the answer for part I would be 1 minus the probability of winning. Okay? If you want the probability of not winning. So probability of not winning is 1 minus probability of winning. And that's equal to 1 minus what we've got in the first part, which is 1 out of 50. And that would equal to 49 out of 50. Now, as a decimal, this answer, if we were to put that in our calculators and press the SD button, we would get 98, or 0.98, sorry. Okay, or 98 out of 100. That would be the fraction form of that. And as a percentage, if we multiply this by 100, move the decimal place twice to the right, we would get 98%. And those are our answers for 12A and B. Question 13. Tracy buys tickets in a raffle in which 200 tickets are sold and there is only one prize. She has a 40% chance of winning the prize. What is the probability that Tracy will not win the prize? So the probability of not winning, so it's win with a bar on top, is 1 minus the probability of the opposite of this, of the complement of that, which is winning. So that will be 1 minus the chance of winning, which is 40%. 40% as a decimal is the same thing as 0.40 or 0.4. When we subtract those two numbers, we get an answer of 0.6. Question B. How many tickets did Tracy buy? Well, Tracy bought 40% of these because this would mean that she has a high chance of winning the prize. Okay, so since she has 40%, let's calculate that out. 40% of 200, which is the same thing as 40% times 200. Okay, or you can think of this as maybe 40 out of 100 times 200. Okay, if you didn't want to do this with a calculator, you can firstly get 200 divided by 100, then times by 40. So 200 divided by 100 is 2, times by 40 will be 80. Okay, so there are 80 tickets that Tracy bought, and that allows her a 40% chance of winning that prize. Okay? Oh, and I believe that's it. Okay, hopefully that helps you